one more inverse problem because yesterday somebody wanted me to do one and I ran out of time. So I'm going to do one more of the let's find an inverse problem. And then we're going to go to our note sheets and we're going to get a little bit of 1.7 done. We're not going to get, you know, a whole bunch of it done, but we're going to get some 1.7 done. And then if we have time, I want to hand back your last test. All right, so we have a lot to do. So first thing we're going to do is find the inverse of y equals 3x minus 8 over 7x plus 2. Okay, we're finding the inverse. Now, who can get me started? Switch the x and the y, and I switch them all. So now it's going to have two y's in it. I switch them all. Everything that was an x becomes a y, and vice versa. All right? It isn't. It's an extra problem I'm doing for you, so you should be writing this down. Paul?
Distribute the bottom to the x.
Yep, I'm going to bring this over here. And like Paul said, when you bring it over, yeah, this is an extra problem we're doing for extra practice because this is a GTQ, guaranteed test question.
Oh, the GTQ.
Right? So Paul says bring this guy over here, distribute it. All right, now what? This is the step we sometimes forget. All the y's on the same side. So you're just going to move things around so that anything with a y is on one side and anything without a y is on the other side. Right? Now what do?
Pick up the y.
Take out the y. This is why you put them on the same side, so you can pull it out, and now how many y's are in the problem? How many y? Just one. That's good news, because your job is to get y by itself, so y will be, and I'm going to divide both sides by the parentheses, right? So my inverse is negative 2x minus 8 over 7x minus 3. All right, so one more time through those steps. First step, switch the variables. Second step, bring your denominator over and distribute it. Get all the y's on the same side. Factor them out and then divide to get your answer. Okay? Now, note sheets. Here we go, 1.7. It's got a bunch of different kinds of word problems in it, but I'm going to focus us a little bit on a certain few kinds. All right, so we are on 1.7 note sheets. 1.7, we're looking at 1A. Do not be confused. It says write an expression that says 6 more than twice a number.
2x plus 6.
2x plus 6. Ethan writes all over it. Now, he used x. Could you use a different letter? Yes, you could. You could say 2n plus 6 or 2w, whatever you wanted. You could do, but that's right. Twice a number means 2 times. 6 more than means plus. Beautiful. Now, be careful with this one. 6 less than 4 times the number. Oh, 4x minus 6. You people are awesome. It says take 4 times the number and then 6 less than that. So subtract 6 from 4 times the number. Beautiful. 24% of a number. 0.24n. Beautiful, beautiful, beautiful. Remember, 24% decimally is 0.24. If you don't know that, we're in trouble. 24% means 24 divided by 100. That's 0.24. In mathematics, the word of always means times. So we're taking 0.24 times the number. 24% of the number means 0.24 times X, or N, whatever number letter you're using. Okay? In math, of means times. Okay? So anytime it says, 30% of something, you're going to be multiplying. Write an expression for the final cost of an item. If the original price is X, there is a 15% discount and a 7% tax. This is important. This is part of your everyday life. When you go shopping, unless you're one of the disgustingly rich people, you like to buy stuff on sale, right? So you've got discounts, but then every time you check out, you have to pay tax. So how is all that calculated? Well, you just trust that the cashier is pressing all the right buttons and the computer does it all. But how do we actually do that by hand? Here is the original price. So I go up to the sales lady or salesman, and I hand her my, let's say I'm getting a new sweater, okay, X dollars. But it's on sale for 15% off. What does the computer do? Exactly. Awesome. We multiply it by 0.85. Now my guess is many of you in the room were saying, you multiply it by 0.15. Robbie says, no, that's wasted effort. If I multiply it by 0.15, that tells me how much I'm going to save, and then I have to subtract that to get how much I'm going to pay, right? Robbie says, bag it. If I'm not paying 15%, then I am paying 85%. But, I got to multiply by something else because now I got to pay 7%. 1.07. I love you guys. This is awesome. Nobody ever guesses this right to start with. Good work.
Where'd you get the one from? Because I didn't say one. I just said 0.07.
Let me believe you said it. It made me happy. Let me believe you said it. Where did the one come from? Well, if you're adding the tax on, you have to pay 100% of what you were paying before, plus an extra 7%. Look, this came from taking 100% minus 15%, because we were taking 15% off. This number comes from taking 100% and adding 7%, because we're adding it on. When you do these problems, please start with 100. And then if it's a discount, subtract from 100. If it's an add-on, add it to 100. Okay, let me say that again. When you're doing these problems, start with 100 and either add on the add-on, which is usually tax, or subtract from 100 the discount. This is the answer to that problem. Problem number D. That is the answer to D. So where did the 85 come from? 100 minus 15. Where did the 1.07 come from? 100 plus 7. All right, now look, E only has 1%. I want you to start with 100. Is this going to be 100 plus 7 or 100 minus 7? 100 plus, because I'm getting a raise, so that would be 1.07x. If x is my salary right now, if I'm getting a 7% raise, then that means next year I get 100% plus 7 more percent. 107%, 1.07. Let's skip down and do H. What is the final cost of an item if the original price is X? This is H. I'm doing problem H. I'm skipped. There is a 20% discount, so I'm going to lose 20%, and a 7% tax. Okay, so what am I gonna multiply by? I'm gonna have my X, and then what am I gonna multiply by? 80%, 0.80, and then 1.07.
Bless you, bless
Does
you,
that make sense to everybody?
bless you. Margo.
All right, let's finish up F and G. They're a little bit different. The area of a rectangle whose width is 3 less than its length. Okay, now wait, I'm gonna draw a picture. There's my rectangle. And it says the width is 3 less than the length. How do you think I should label the sides here? The width is 3 less than the length.
L minus 3.
And L?
L, yeah.
Marley says, I'm gonna let the length be L, and then the width would be L minus 3. Does that make sense to everybody? It says the width is 3 less than the length. I think she's right. Now, what would my formula for area be? Length times width. There we go. That is the answer to F. Good work, Marley. Now let's see if you can do G, folks. I know Marley can. Can anybody else do G? We got another rectangle. What do we know this time? The length is twice the width.
2L.
So be careful. We'll call this W, and then this would be 2W.
No,
Now you don't want L and 2L, do you? No, because the width, or excuse me, the length is 2 times the width. Now, if that's W, this is W, and this is 2W. This time I want perimeter, folks. I don't want area. It says find the perimeter. What does perimeter mean? Add them all up, distance around. So it'll be W and 2W and W and 2W. We ought to be able to combine that into what? Oh, no W squares. We're adding 6 W's. 1 W and 1 W and 2 W's and 2 W's adds up to 6 W's. When do I get W squares? When I multiply them. So if I were doing an area problem, I would get a square. All right, 3 more and we'll be done with this. I want to do 2, A, B, and C. So your favorite teacher received a 3.2% salary increase. Her original salary was 1, 2, 3, 4, 5. What will my new salary be? All right. Well, I'm assuming I'm your favorite teacher. What will my new salary be if I get a 3.2% increase? Now, what am I going to multiply by? It's a 3.2% increase. Start with 100 and then add it. So I'm going to multiply by 1.032. So 1, 2, 3, 4, 5 times 1.032.
Why is it 032?
Because it was 3.2%, and decimally, remember that's 2 decimal places, so it's 0.032 added to 1. You always start with 1 and either subtract or add the percentage. So next year my salary will be 12740.04. Anybody want to take a wild guess what my starting salary at Cathedral High School was back in the fall of 1981? What? 26.5. Anybody want to take another guess?
I don't know the inflation.
23.
13.5. 16.
Yeah, it was
8.
up or down.
Oh, way down.
Okay.
13.5.
Way down. Way down from that.
8.
9,000.
$6,800.
No way.
And I was the yearbook moderator, so I got an additional $400 for doing that, so I made $7,200 my first year. And now it was 1981, but we were in the middle of a recession. And keep in mind, I was a straight A student, the top student in my class, about valedictorian and all that stuff, and I made $6,800. Yeah, but I love my job. Yeah, look at me now. Well, I make more than that, so I'll say that. I'm happy about that. All right, last year, a Precal book cost $89.50. This year, okay, so this was last year. This year, it costs $97.75. Find the percent of increase. All right, so this is a little bit different kind of problem. Does anybody remember from first year algebra, long time ago for you, how you find percent of increase or decrease?
You defined 89 divided by 27.
You are close. You are close. What that would do is tell you last year's price was what percentage of this year's price. It doesn't give you the percent change. Okay, now wait a minute. Change. So what we're going to do is find out how much it has changed, and we would do that by subtracting, right? And then we're going to divide that by the original. So I'll write the formula down for you. So the percent change is the change divided by the original. So for us, that would be this number, whatever that equals, divided by 89.5. Now, when you type that into your calculator, please be careful to hit equals. After you type in that numerator, make sure you hit equals, and then divide it by 89.50. And it's about 9.2%. Now, I do want you to add one word to this. You're either going to be going up or down, so in this case, I'll say a 9.2% increase. There will be times when you'll say 9.2% decrease, okay? Increase or decrease. All right, one more. Same kind of problem. Here we go, last one. Originally, it was 23,456, and now it's 18,765. And we want to find the percent decrease. Okay, so how do we do that?
Oh, you can
Subtract. So we'll take 23,456 minus 18,765, and then what do we divide by? 23,456. Always divide by the original. And so that answer will be 23456. Try to give you numbers that are easy to type in. I got just about a 20% decrease. Anybody match that?
Yeah.
Okay, we're going to do the rest of this tomorrow, or whenever I see you again tomorrow, I think. What we're going to do now is I'm going to hand your test back. I will pick these back up. Chris, when you're ready, you can turn off the video.